Hello friends, welcome back to All About Structural Analysis and Design. So this video will be the second type of analysis of doubly reinforced beam. Okay, I have explained in my previous videos what is doubly reinforced beam, why we provide doubly reinforced beam, and also one analysis problem I had solved in my previous videos. So in this video we shall see the second type of analysis problem in doubly reinforced section, that is we have to calculate the reinforcements. The first type was when we need to calculate the ultimate moment of resistance when all the parameters was given. So I will be sharing the link in the description box and also in the top I button. So you can just check out with that video and you can see how to calculate the ultimate moment of resistance when all the parameters are given. So in this video we shall calculate the reinforcements required. If you have gone through my previous videos, I have explained clearly what are the types of reinforcements in the doubly reinforced beam. So in this problem, they have given to find out the reinforcements required for a doubly reinforced beam having width of 300 mm and overall depth 600 mm. And the given factored moment, that is your ultimate moment, is 320 kilonewton meter. You have to use M20 and Fe415 materials. So as usual, we shall write the given data first. So given, what is given is the width, that is B is given. B is equals to 300 mm and overall depth they have mentioned, that is capital D. Okay, that is 600 mm. So what is effective depth, overall depth, clear depth, everything I have explained in one of the videos. That links also I shall give in the description box. And here again ultimate moment, that is factored moment, is nothing but your ultimate moment, which is mu. Mu is equals to 320 kilonewton meter. And materials they have given M20 and Fe415. So FCK is nothing but grade of concrete, that is 20 Newton per mm square, and grade of steel is Fy, that is 415 Newton per mm square. And they have asked to calculate the reinforcements required. Okay, so for tension there will be two types, that is AST1 and AST2, and the compression reinforcement is denoted as ASC. So AST1 is equals to question mark, AST2 again this is we have to find out, and ASC, that is area of compression reinforcement. The combination of AST1 and AST2 is known as total AST. Okay, so they have not given here the cover, effective cover, so we shall assume the effective cover, assuming effective cover D dash, okay, as 50 mm. So our effective depth will be, effective depth is equals to, that is D is equals to D minus D dash. So D is our 600 mm minus 50 mm. So the effective depth is 550 mm. Okay, so you can just make a box for this because as this is required in your further calculations. So you got effective depth as 550 mm. Now what you have to find out is whether this beam is doubly or singly is either you can find out the limiting moment. Okay, when ultimate moment is greater than limiting moment, we conclude that beam as doubly reinforced beam. So that's why we shall calculate the limiting moment of resistance. Okay, mu limit. So our simplified formula for Fe415 is 0.138 FCK BD square. 0.138 FCK BD square. How this formula came, this also I have explained in my previous videos. There will be three different grades, 250, 415 and 500. Okay, so there will be three different values for all the three grades. So we are using Fe415 here, that's why that's mu limit formula becomes 0.138 FCK BD square. Now you have to just substitute in this formula. If you don't want this formula to be used, you can just go to page number 96 and you can use that mu limit formula. Okay, so here we can just substitute here 0.138 into FCK is 20, B is 300 and D is 550 square. So this comes out to be 250.5 mu limit equals to 250.5 kilonewton meter, or into 10 raised to 6 Newton millimeter, and this is equals to 250.5 kilonewton meter. So now you got ultimate the factor moment was given, that is ultimate moment, that is 320 kilonewton meter, and the limiting value for this section, as far as this B and D, you are getting 250.5 kilonewton meter, which is way less than this ultimate moment. Then what you can conclude, as mu is greater than mu limit, then this beam has to be designed or analyzed as a doubly reinforced beam. Okay, since mu is greater than mu limit, therefore the beam should be analyzed as doubly reinforced beam. So this remarks you have to give, analyzed as doubly reinforced beam. Okay, now you got whether the beam is doubly or singly. Okay, from this we can find out. If it was mu limit was less than mu limit was greater than mu, then you can just conclude it as singly reinforced beam. But the mu ultimate moment was greater than mu limit, so it has to be designed as doubly reinforced beam. So that was the conclusion with the calculation of limiting moment. Okay, now what you have to do, you have to just find out the XU max value. Okay, that is XU limiting. XU max by D is equals to XU max by D is equals to 0.48 for FE 415, page number 70. Okay, so this also we have solved many times. So from page number 70 of IS 456 2000. Okay, so for grade FY 415, that XU max by D value is 0.48. Okay, page number 70, IS 456, that also I will mention here, IS 456 2000. Okay, now XU max value equals to 0.48 into 550. So XU max equals to 264 mm. Okay, so this was not singly reinforced beam, this is doubly reinforced beam. So XU max, you can just equate it to XU. Okay, this again this value will be required to calculate the AST value. Now what you have to do is you have to find out ASC as well as AST1 and AST2. If you go to page number 96 again here of IS 456 2000, section with compression reinforcement. Okay, so G 1.2 they have given section with compression reinforcement on page number 96 of IS 456 2000. So here they have given one formula is mu minus mu limit equal to FSC ASC D minus D dash. This formula is given to calculate ASC. Then here they have given AST equals to AST1 plus AST2. AST1 I will show how to calculate, and AST2 directly formula they have given, AC FSC divided by 0.87 FY. Now what we have to do is, with the help of this formula mu minus mu limit equal to FSC AC D minus D dash, we have to calculate area of compression reinforcement, that is ASC. Because mu is known, already given, mu limit we have calculated, D is known, D dash is known. Okay, the only unknown thing here is FSC. AC we have to calculate, that we can leave. Only unknown thing is FSC. FSC, what is FSC is design stress in compression reinforcement. So this value will be getting on getting in SP16, that is special publication 16, our design aid for reinforcement, this one, reinforced concrete structures. Okay, so this is your SP16 special publication 16. On page number 13 you will get one table F. Okay, here they have mentioned stress in compression reinforcement FSC in Newton per mm square in doubly reinforced beams, okay, with cold worked bars. So here only two grades they have given, 415 and 500. Okay, for this you require the ratio D dash by D, effective cover by effective depth, that you have to find out. There are four values or four ratios: 0.05, 0.1, 0.15, 0.2. Now your next step in this problem is to calculate or to find out the ratio of effective cover divided by effective depth and see the ratio where it lies. Okay, and the grade given is 415, so you need to take this horizontal values 355, 353, 342 and 329 based upon the ratio. You have to find out now stress in compression reinforcement FSC. Okay, so let's calculate this. So compressive stress in compression steel. Now compressive stress in compression steel. Okay, so for that thing you need to find out the ratio first. D dash by D. D dash was 50, D is 550, correct? So you'll be getting 0.091. Now you have to go back to the table number F of SP16 and you have to see where it lies. So it lies between 0.05 and 0.1, and for 415 grade of steel, so 0.05 is having 355 Newton per mm square and 0.1 is having 353 Newton per mm square. Now what you have to do is you have to go for interpolation method and you have to find out the exact value of compressive stress in compressive steel for that particular ratio, that is 0.091. So by interpolation method, okay, so this column will write D dash by D and this will write FSC. So for 0.05 it was 355 Newton per mm square, okay, and for 0.1 it was 353 Newton per mm square. Now you have to find out the value for this ratio 0.091. So the interpolation method is you have to take this greater value 355, and if you see carefully here the value of FSC is decreasing, how the ratio is getting increased. Okay, so from 355 it decreased to 353 for the ratio 0.1. So it means it is decreasing, that's why you have to use here minus sign. So in one of the problems, design problems, I had shown you when this value, not compressive stress in compressive steel, the another value which was increasing, that's why we had used positive sign here. But now the values are decreasing, that's why we have to use negative sign here. Okay, so minus this 355 minus 353, okay, greater minus smaller, again 0.1 minus 0.05 into for which value you are finding out, that is 0.091 minus the least value of D dash by D, that is 0.05. Then this works out to be FSC at 0.091 will be 353.36. 36 Newton per mm square, 353.36 Newton per mm square. If you just check out that value and this ratio 0.091 is very close to 0.1, and whatever FSC value you got at 0.091 is slightly greater than 353. Okay, so your value is 353.36 and the value at 0.1 was 353. So it lies very close to this 353 value and it is in the range 355 to 353. So you can just conclude that your FSC value whatever you have calculated is correct. Okay, so now again go back to page number 96 of IS 456 2000 and just see this equation, mu minus mu limit equal to FSC AC D minus D dash. Now this was missing, FSC was missing, you have calculated, and now you can go for the calculation of area of compression steel, okay, from this equation. So you can just write down here from page number 96. From page number 96, IS 456 2000. So your IS 456 2000 says mu minus mu limit equals to FSC AC D minus D dash. Now this AC is missing, so AC equals to mu minus mu limit divided by FSC D minus D dash. So ASC equals to mu was 320 into 10 raised to 6 minus mu limit was 250.5 into 10 raised to 6 divided by FSC value you got as 353.36, okay, Newton per mm square. D is 550 minus D dash is 50. So ASC comes out to be 393.36 mm square. So now you got one of the reinforcements which was asked in the problem, that is area of compression steel. Now one more type of steel is area in tension, okay, tension zone. Now area of tension steel, okay. So if you go back to page number 96, they have given how to calculate AST2. AST1 is nothing but the area of reinforcement required for singly reinforced section, okay. In one of the videos which I will be sharing the link in the description box, I have told you what is the difference between AST1 and AST2, okay. So AST1 is nothing but area of reinforcement in tension zone when the section is singly reinforced beam. And how you calculate AST in singly reinforced beam is from page number 96. First formula, okay, XU by D equal to 0.87 Fy AST divided by 0.36 FCK B into D. The only change in the notations will be here you have to write as AST1 and you have to calculate. This D and this D will be getting cancelled, so directly you can find out AST1. XU also you have calculated, that is 264 mm in this problem. So from this formula you have to calculate AST1. So page number 96 again, XU equals to 0.87 Fy. Remember you have to denote it as AST1, 0.36 FCK B. So XU is known 264, so you can just transfer all these things into this side. So AST1 will be AST1 equals to XU 0.36 FCK B divided by 0.87 Fy. So just substitute. XU is 264, we had calculated, 0.36, FCK is 20, B is 300, okay, divided by 0.87 into 415, Fy was 415. So this AST1 comes out to be, after substituting, AST1 is 1579.39 mm square. So this is how you calculate the AST1. Now AST2 you can directly find out, okay, which was given in page number 96. So now AST2 is FSC ASC divided by 0.87 Fy. Page number 96 again, okay. So AST2 is FSC was 353.36, ASC you calculated 393.36, 36 divided by 0.87 into 415, and the AST2 comes out to be 384.98 mm square. And here you can conclude, therefore total AST equals to AST1 plus AST2. AST1 was 1579.39 plus 384.98. So AST is 1964.37 mm square. So this is your AST, and ASC you have calculated 393.36 mm square. So these were the things which were asked, the reinforcements in the doubly reinforced beam. So AST also you have calculated, ASC also you have calculated. So I think I have cleared all the doubts how to calculate the reinforcements when only width and depth is given, provided ultimate moment was also given. So if you have understood this video, please like it, share it, and don't forget to subscribe all about structural analysis and design, and also press the bell icon for the latest notifications of my videos in civil and structural engineering. Thank you friends.